Finding domain and range of a function. When we talk about the function, we said that the function is a relation between the input and output. For every one input that it takes, it gives us one output to be a function. Now the question is, what value the function can take as an input? Those are the domain of the function. Domain means all of the possible input values, all of the possible x values. Are we allowed to replace any number for x? Are we allowed to just plug in any number as an input? No, that is the question when we want to find the domain. For many functions, we are allowed to replace all real numbers. We don't have any restriction. But some functions have some types of restriction. Like fractions. If we have a fraction, we know that we can replace any number for x except the number that makes the denominator 0. So if anytime you see a fraction and they ask you to find the domain, that means find all of the possible x values that you can plug in for x. I say, okay, from negative infinity to positive infinity, I can replace any number for x except the number that makes the denominator 0. Now the question is, what number makes the denominator 0? So just whatever is in the denominator, set it equal to 0. And see what number makes it equal to 0. Isolate the x. Add 6 to the both sides. So 3x is equal to 6. Divide by 3. And we find that x equal 2 is the number that makes the denominator 0. That means I cannot replace x by 2. I am allowed to replace any number for x except 2. So if I want to show the domain in interval notation, that means from negative infinity to positive infinity, if 2 is over here, I can replace all these numbers and all these numbers except 2. So I have to exclude 2 out of the all real numbers. So that's why I have to write it as 2 separate intervals. One interval for the numbers less than 2 and one interval for the numbers that are more than 2. So one interval starts from negative infinity to 2. Since 2 is not included, make sure to leave a parenthesis. Another interval starts from 2 to infinity. And you know that all numbers can be part of the domain. So that I will put a u in between that shows it all together, the union of all these intervals. So every time we have a fraction, we set the denominator equal to 0, and whatever number we find for x, because it's the number that makes the denominator 0, we exclude that number, or maybe it's more than one number, all the numbers from all sets of all real numbers. Let's look at another example. We want to find the domain of a function g. When I look at the function g, I say, okay, I can replace x by 1, by 2, by -1, by -2, by 1/2, any number. I don't see any restriction that stops me by putting some numbers there. I don't see any fraction that wants to be a 0 or anything else. So no restriction. When there is no restriction, domain is all real number. And how do we show all real number when we want to show as an interval notation? That means all the numbers from negative infinity to positive infinity. Okay. Now let's look at part C. We have a radical. It's a radical function. Am I allowed to replace any number for x? Can I replace x by 1? Yeah, because it gives me 1 minus 1, which is 0. Can I replace x by 2? 2 minus 1 is 1. 3, 4, 5. But am I allowed to replace x by -1? If I replace x by -1, I will get -2 under the radical. And we talked about this one, that every time the index of the radical is even number, like 2, 4, 6, inside the radical cannot be negative. So I'm not allowed to replace the number that makes under the radical negative. So for radical function, we have to make sure that under the radical, it's positive or 0. Positive means greater than or equal to 0. So to make sure what number we can replace for x, whatever is inside the radical, only inside the radical. I don't care about the 3 or the positive 8. They can be any number, positive, negative. I don't care about them. Only under the radical. Under the radical, whatever it is, you have to set it greater than or equal to 0, because you want to make sure that it's positive or 0. It doesn't give you a negative number. And then solve for x. Find the x. That means adding 1 to the both sides. So x must be greater than or equal to 1. These are the numbers that you can replace for x. Only the numbers that are greater than or equal to 1. But I have to show that as an interval notation. From negative infinity to positive infinity, 1 is here, 1 is included, I can replace 1. But all the numbers that are greater than 1, I mean, these numbers can be plugged in for x. Which means the interval is from 1 to infinity. Infinity is always a parenthesis. Since 1 is included, we have equal sign here. We have to leave a bracket for 1. And that's my domain. I have another example. That's a radical function again, but this time the index is 3. It's an odd number. Do we have any restriction for odd index radicals? No, because when the index is odd, we can have both of the negative and positive under the radical. So there is no restriction in this case. And when there is no restriction, that means the domain is all real number. That means from negative infinity to positive infinity. So when the index is odd, no restriction. Now we want to find the domain and the range. What is the range? Range means all possible y values. When we talk about the domain, that means we are talking about the possible x values. When we talk about the range, that means y values. Finding the range is not as easy as the domains. But if you have a graph, it's very easy to find the range. So let's look at the graph. How we can find the domain and range of these two functions. We said the domain means all possible x values. X values means from left to right. You have to find the x values that cover the graph from left to right. So the very left part of this graph is over here and all the way to this point. From left to right, the domain starts from this point to this point. The x values are from this point to that point. And those points are -1, -2, -3, -4. From -4 to -1. That means the only possible x values that this graph takes are the numbers from -4 to -1. So for writing the domain, it starts from left to right, so from -4 to -1. And we put bracket because both of them are included because we see closed dots here. But when we talk about the range, that means we're talking about the y values. This time, we are looking at the graph from the bottom to the top because we want to see what part of the y-axis is covered by the graph. So the very bottom part of the graph is over here, and on the y-axis is -2, and it's going up all the way to this point. That's the highest part of the graph, which is 2. So the range is between these two numbers. That's the range. That means from -2 to 2. And both of them are included again because we don't have any open dot for them. So that's a closed dot, and there is no open dot here. That means it's closed dot again. Let's look at part B. Find a domain and range. Again, for the domain, we look at the graph from left to right. And you see that this graph has an arrow on the both sides, which means that on the left side, the graph is going up and going to the left. It's going up and it's going to the left all the way to the infinity. So when you see the arrows tells you going to infinity. So that means for the domain, we have from negative infinity to positive infinity. Because as long as it's going up, it's going to the left and right because it doesn't go up straight. It's going to the left and right. So the domain is all real numbers from negative infinity to positive infinity. But what about the range? Range means the y values from the bottom to the top part of the graph. The very bottom part of the graph is here, which is negative 4. But for the top part, you see that the graph is going up all the way to infinity. It's going up all the way to infinity. So for the range, we say the range is from negative 4 to infinity. And negative 4 is included because there is no hole or there is no open dot.